Hello everyone and welcome back. In the last lecture we built a linear regression model, and in this lecture we'll evaluate our model. Great. So I'll start by looking at our house dataset by calling the head method. So here we have house ID. What I will do is I'll see how our model predicted the price for a certain house. So let me copy this house ID, and what we can do is we can save this in some variable. I'll just call it house1, and that will be equal to our house data frame, and then we'll simply index the ID column. Okay, so we'll say house, and then we'll index the ID column, and we'll set that to be equal to that specific ID. Okay, so that's house1. So if I simply call house1, we have one row with all the house information, with all information regarding that house. Okay, from here we can simply index the price and see the price of that house. So if I say house1 and then simply index the price column, we see that the actual price of the house is 538,000. And here we see that this house is at index 1, so row 0, row 1, right? To see how well our model predicts the price for that house, what we can do is, so in the previous lecture we have saved our prediction in a variable called prediction, right? So I can call that object prediction and then simply pass the index of the row for our house, which is 1 in this case. So if I run this, so our model predicts the price of the house to be 724,000, whereas the actual price is 538,000. So that's just an example of how our model predicted the price of that specific house. And to see how good or how well our prediction did, we can plot a scatter plot of the prediction versus the actual price and see the relationship from there. So we can call the scatter method plt.scatter, and then we'll pass, so on the x-axis let's pass y-test, and on the y-axis we'll pass prediction. So y-test is the actual price for our house, whereas this prediction is the price our model predicts. Okay, let me run this. So here we have a scatter plot. Let me make the plot a bit bigger. plt.figure, let's pass the fig size attribute and set the size to be 10 by 7. Let's run it again. Okay, so this is a scatter plot of the actual price versus prediction, and what we can tell from this is, if you see more of like a straight line or linear relationship, we can tell that our model did good compared to the actual price. Okay, if you see kind of a linear relationship, that means our linear regression model is doing good compared to the actual price. So that's what you can tell from a scatter plot. If you see more of a linear relationship, that means the model is good. Okay, what I want to show you next is evaluate some of the coefficients that we used. If I call x, we know that we have used 10 features, right? And we can call a method known as coefficient to find out the coefficient values for our model. So if I say model.coefficient underscore, that's the name of the method, you'll see a coefficient value for each of our features. Okay, remember the features that we used? So these are the 10 features: bedroom, bathroom, square living, and so on. And that's the coefficient for our features. What we can do is we can use this coefficient and map it to the specific feature and see what kind of effect it has. Okay, to do that, we can create a data frame by using pandas data frame method. So pd.data frame, and then we'll use this model.coefficient. So model.coefficient underscore, so we'll use those values and we'll map it with the specific features that we defined earlier. So we have x.columns, and then for columns we can name it, let's say, coefficient value or whatever you want. Coefficient, let's say, value. And we can save this in a variable called data frame coefficient. Okay, now let's see what our data frame coefficient looks like. So if I run this, so here we have our 10 features: bedroom, bathroom, square living, and so on. And then we have our coefficient values here. Okay, so what does this tell us? So this tells us the relationship or the weight of each of our features on the target price. So for instance, if you consider the specific feature square feet living, it means that a 1 unit increase in the square feet living value will result in an increase in $293 in the price of your house. Okay, so that means if all the other conditions are kept constant. And similarly, if you take another feature here, for instance bathrooms, and if there is like a 1 unit increase in this feature bathroom, that could be maybe 1 additional bathroom, that's associated with an increase of this much amount in your target price. Okay, so that's the general information that you can get from this coefficient method. So again, this is an average value. Some of it might not be, so this doesn't look realistic. An increase in bedroom, according to this, an increase in a bedroom will result in a decrease in the value of the house. But those are the general information that you get about your features. Okay, that's the coefficient method, and you can read more about this coefficient method from the scikit documentation. Just wanted to show you that method. Okay, and earlier I mentioned that there's a method known as intercept. So you can call the intercept method on your model to see where your linear regression line crosses the y-axis. That's the y-intercept. So model.intercept, that's the method name, intercept underscore. So the value is negative 269,000. So that's where this line crosses the y-axis. The next thing I want to talk about is what is known as the root mean square error. So this is one of the methods that we can use to evaluate our linear regression model, root mean square error. You can read more about it online or Wikipedia. It's a common method used. What it does is we take the difference between the actual value and our prediction, and once we take the difference, we'll calculate the mean of those and finally take the square root of that. Okay, we can read more about it here. Let's consider this regression line. So the blue dots are the actual prices or the actual value, whereas this red regression line indicates your prediction. So what we do is you take 1 point and then calculate the distance from the line. So take that difference and then you take another point, calculate the distance from the line, and then you take the mean of the difference of each of your points in your data set. Okay, and that will give you the mean square error. That's also another method. And then once you get your mean square error, you take the square root of your mean square error, and that gives you the root mean square error. In regression problems, so you want to minimize this root mean square error. Okay, that means you want the distance to be as close to your regression fit line, right? So the closer the data points are to your regression line, or if you have a lot of those data points or data sets close to your regression fit line, that means your model predicts very well compared to the actual price. Okay, so that's how you calculate the root mean square error, and every time you want that root mean square error to be as low as possible. Okay, for us, scikit-learn has this method. So we'll import the matrix, we'll import this matrix library, and then we can call a method known as the mean square error method to calculate the mean square error, and then we can find out the root mean square error from there. Great, we'll see that in the next lecture. Thank you everyone.